Okay, ladies and gentlemen, today's lesson is moving straight ahead, 3.5. And 3.5 is all about finding the point of intersection. Our learning target is this. I can find the point of intersection using two different equations. Okay, now take a deep breath, in and out. Relax, because this is just a little bit of a kind of a brain stretch. It's all stuff we've done before. It's just finding a different way of thinking about it. Okay, so here are your notes. You don't need to copy down the whole thing, but maybe you want to put down the graph and the estimate and the general story here. Mr. Briggs has challenged Mr. Porter to a pogo stick race. Mr. Briggs is traveling 5 feet per second down the road and has a 15-second head start because I cheated. Mr. Porter, on the other hand, started after me and moves at a pace of 10 feet per second. He's much, much faster. I mean, look at the guy. He's like a sinewy spring of a man. Okay. How long before Mr. Porter and Mr. Briggs are tied? How long before Mr. Porter catches up to me? So, first let's think, what is this going to look like on a graph? On a graph, I would have my x and y axis here. This would be time, and this would be distance. We would expect Mr. Porter to be right here and increasing at a really fast rate. Mr. Briggs, on the other hand, okay, let me use a different color marker for this, I would be getting a head start, but moving at a slower pace. And at some point, we're going to cross. At some point, he's going to go much faster than me and meet up with me at some unknown time and at some unknown distance. What we want to find out is at what distance and at what time is he going to be catching up to me. So, our equations are where we're going to find this secret. We're going to do this without having to do a single graph, without having to use any graph paper at all. It's a beautiful thing. Now, what are our equations? Well, Mr. Briggs, okay, my equation is my distance, my y value, is equal to 5 times x plus 15, because I've got to account for that 15-second head start. Okay? Or I'm sorry, not 15-second, I should say 15 foot. Okay? Now, in this particular equation, Mr. Porter, he's going y equals 10 times x. But he does not have that head start. Okay? He does not have a 10-foot, he does not have that 15-foot head start. So, I am going to try to figure out, using just math, where do we cross? So, let's take a look at these equations. Mine is 5x plus 15. His is 10 times x. What do you notice about them, though? Y equals 5x plus 15. Y equals 10x. Well, if 10x equals y, and 5x equals y, and if we're assuming y is going to be the same thing, can't we just make these things equal to each other? If they're both equal to y, can't they be equal to each other? If this equals y and that equals y, then they're both equal to each other, right? It makes sense. So, let's rewrite this problem. 5x plus 15 at some point, we don't know when, has to intersect 10x. We don't know where. But we're going to find out. And we're going to find out by taking 5x off of each side. And when we take 5x off of each side, we're left with 15 equals 5x. And if we divide that, we get x equals 3. So, What does that mean? What's our x value represent? Think back to the last lesson. In this problem, what is x? If x is our constant, if x is our coefficient, then, or not our coefficient, our constant, then that is time. And it's saying that after 3 seconds, Mr. Porter will have caught up to me. Okay? Now, if it's 3 seconds that he's caught up to me, I want to know what's the distance going to be. Well, let's try it out. I'm going to do this in a red pen. If 5 times that 3 seconds that we think we're going to be tied at plus 15, well, 5 times 3 is 15. 15 plus 15 is going to be 30. And then, if I set this one here, y equals 10 times 3, which is what we say it's going to be, I get y equals 30. So, sure enough, at 3 seconds and 30 feet, we will meet. Our lines will intersect. If you don't believe me, plug both of these questions into a graphing calculator. Go ahead, do it. I'll wait. Pause this. Put in y equals 10x and put in y equals 5x plus 15. And you will see that at 3 seconds, okay, when x is 3, we will both be at 30. So using just math, we have found that point of intersection. We've found when these two lines meet. So, what are the steps for finding the point of intersection? And this you will definitely want in your notes. 1, find your equations. 2, set them equal to each other and find x. 3, using one of the original equations, find y. Okay, you've already found x, find y. And then you now have a point. You have a point where you can reference. You have that point where these two lines intersect. Let's go ahead and solve it. Now I've got two equations here. Y equals 4x minus 1 and y equals 2x plus 7. Well, they both equal y, so let's set them equal to each other. 4x minus 1 has to equal, I wrote that really big, 2x plus 7. Well, what's going to be easier? It's going to be easier to bring 4 over or 2 over. Well, I think bringing 2 over is going to be easier. So I subtract 2x from each side. This cancels out. This subtracts, and I'm left with 2x over here minus 1 equals 7. Well, now I want to get rid of that 1, so I add 1 to each side, and I get 2x equals 8, and divide both by 2, I get x equals 4. Ding, 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 ding. X equals 4. I have the first point of my point of intersection. So if x equals 4, I want to know what y is going to be. So I take one of my original equations. Let's take 4x minus 1. And let's pop in our answer for x. So I have y equals 4 times 4 minus 1. Okay? And 4 times 4 is 16, minus 1, y equals 15. And now I have my point of intersection. So, the question is, when is y equals 4x minus 1 going to be equal to 2x plus 7? When are those two lines going to meet? The answer is 4:15. When x is 4 and y is 15. Okay. Your coursework, ladies and gentlemen, for this last lesson in 3 is finding the point of intersection. And the lesson is going to be on page 55 and 56, A through D. And you'll be doing problems 24 through 27, 42, and 46. Have fun.